Hello and welcome to this video. So a while ago I did a video about the Mandelbrot set, and that video was primarily just to explain the underlying complex maths that's going on, because I felt other videos about this subject didn't really explain it properly. Now the application that I wrote in that video wasn't particularly good. It was extremely basic, it wasn't optimized, and it only generated a relatively small black and white image. But it generated some comments asking, how do you do those things? How do you do the zooming in, magnifying on various areas? And I said to one commenter, it'd be better if I did a new video about it. Now that was some time ago and I never got around to doing it. So this video is me getting around to doing it. So we're going to be writing this application in C#, and I'm going to be using WinForms mainly because it's quick and convenient. It's a lot easier to knock things together quickly in WinForms than it is in something like WPF. And if I did do it in WPF, the code would be a lot larger, the video would be a lot longer. So we're going to stick to WinForms just for convenience, basically. Now this application is still going to be limited, right, because we're going to be using double precision floating points for the calculations, and this limits how far you can zoom in, because doubles only have obviously so much precision. Now there are ways around that. You can use arbitrary size integers and use integer expansion mathematics, but that would be just out of the scope of this video, so we're just going to use doubles. We're also going to be dipping into multitasking as well. Why not? So let's get going. Alright, so here we are. This is Visual Studio 2022. So let's create a new project. Alright, so let's just close that. I'm going to rename Form 1 to UI, reopen it, give it a title. So I'm going to set the background and foreground colors of this window to sort of a darker theme. So we'll set the background color to, I think, 32, 32, 32. Foreground color to white. So what I typically do with a form like this is I will drop in right on top of the form table layout panel like this, and then I will dock it to fill the entire window. And this basically gives you the same kind of functionality as in WPF, where you use the grid, because this is basically the same kind of thing. First of all, let's figure out how we're going to do this, how we're going to set up this user interface. So we're going to need to be able to edit various parameters, like maximum iterations and things like that. So we're going to need the maximum number of iterations. We're going to need the number of threads that we're going to use to render the images, the view offsets, and there are two values for that, like the real and imaginary offsets. That's where you're actually focused in on the set. So that's 4 so far. We need the palette scaling, and that's just, I'll come to that later. It's to do with enhancing the colors. We're going to need the magnification as well. So that's basically 6 parameters that we need to adjust. So what we're going to do, we're going to go into rows and columns here. We're going to leave 2 columns. Actually, we're going to need 3 columns. So, all right, and rows. Right, we need 6 rows for the parameters, and we're also going to need a 7th row, just left over. So we've got 2 at the moment, so we need to add 5 more. So first of all, let's drop a label in here. Max iterations. We'll do view offset next. Okay, so let's select all of those, and we'll dock those to the center right, and set the text align to right. There we go. Now we're going to need some controls to be able to adjust these settings, so I'll use a numeric up down for that. So max iterations, we'll default this to 50, I think, and we'll give it a minimum of 10. I don't think we're going to really need to go lower than that, and a maximum, well, let's give it 1,000,000, and no decimal place. view offset. Okay, we're going to need the maximum precision with this. So maximum is 100 there. We'll go minimum -100. Actually, we're never going to need to go that far out. Let's do it to 10. Decimal places here, I'm going to set 16. Actually, I should have been doing this on both of those, shouldn't I? Because they're the same. Okay. Palette scale. Well, this is a scalar value, so it needs to be... We'll set a default value of 15, say. And the minimum is 1. Because 0 is obviously no good for a scalar. Maximum, oh, I don't know. Set a million again. We'll have 2 decimal places for that, I think. Right, zoom. Actually, no, what we'll do, we'll call this magnification. Because this value is going to be exponential. Threads. Okay, we're going to set this to 4. The minimum of 1. Get all these together. And we'll dock them to the right, I think. Let's also change the font. And all of these we're going to set auto size. All of these we can set the first 6 rows to auto size. Now with the columns, we'll set the first column to 100% and the second 2 columns again to auto size. So I'll set the text align to right. Okay, we're going to need something to draw the image onto. So I'll do that with a picture box. So we'll drop the picture box here. And we'll cause it to span. So how many we've got to span? 1, 2, 3, 7. So this is going to be row span 7. And we're going to dock that fully. And then that will cover that entire area. We're going to set the background image mode to zoom. And we're going to set the background color of this to black. Need a couple of buttons. Is a flat style, I think. Okay, we've got 1 button there, 1 button there. Dock these and make them a little bit taller. Okay, so this button is going to be the abort button, and this one is going to be the render button. We'll actually use bold here, 14 point. Set the background color here to something to make them stand out a bit. 64 should do. So let's name these. This is going to be render button, abort button, max iterations control, view offset A control, palette scale control, zoom control, threads control. This is the preview control. Might tweak it a bit later, but for now that should be functional. Alright, so let's view code here. Alright, so what I'm going to do is set up some properties. But before I do that, I'm just going to set up a new class, my extensions, in case I need to make any extension methods, which I will. So one of the extension methods I'm going to need to make is a way to safely set numeric up downs, because if you try and programmatically set a value that's above or below the minimum maximum values, it will cause an exception. Let's first make a clamp. Okay, you want the maximum between the minimum value, you want the minimum between those two. Yeah, that's right. Okay, we'll set up a static void. We'll call this safe set, and this is going to be this numeric up down MUD and a decimal value. And basically we're saying nud value equals clamp, and it's going to be nud minimum, nud maximum. There we go. Okay, so going back in here, we're going to create a property for the iterations. So this can be private, not going to be needed anywhere else. So int max iterations. So get an int iterations control value, and to set max iterations control safe set value. There we go. So that's max iterations. Threads is also an int. So we need offset A, offset B. These are doubles, decimal, and we need view offset B as well. Okay, so those are the properties. All right, so we're going to be passing a load of parameters to whatever method we create to draw the set. And I don't really want to be having a massive parameter list for the method. So what I'm going to do is I'm going to encapsulate all of that in a context class. So this is going to hold all of the information that we're going to need. So doubles we're going to need are the palette scale, offset A, offset B. We'll call this mag rather than zoom. And also we're going to need to pre-calculate some values. So basically half of the height and half of the width, h width and h height. So ints. So we're going to have the width and height of the image we're generating. Maximum iterations is also an int. Okay, we're also going to need a color palette, color array. We'll just call that palette, a color, which is going to represent inner color. So this is going to represent points, that just go on to the maximum iterations. Typically you'll color that black, but I'll leave it so that we can change it if we need to. Okay, we're going to need some way to access these externally. So let's create some properties. So let's make the constructor. We're just going to pass in a color array and color inner. Alright. Right, now we need something to set all these values. Void set values, and also we need to do some pre-calculation of certain things as well. Let's get all of these in. So we're going to need the palette scale, the offset A, offset B, the zoom, the width of the image, the height of the image, maximum iterations. Okay, palette scale equals P scale. Let's figure that one out. Offset A, let's figure that one. That's going to be zoom, width, height equals h, max iteration. So let's pre-calculate half height. Why did you do that? What? Oh, half height is going to be h divided by 2, half width, and the magnification, remember it's exponential, so we need to work out, but that's not enough as it is. What we want to reduce the image's dimensions to the complex plane, right? And what we really we want the entire image of the full set. So when you're displaying the full set, you want the height of the image to represent basically 3 imaginary units. So we can do that just simply by dividing the height by 3 and then multiplying it by the exponential zoom value. And that's it. That should pre-calculate all of the values we need. Right, we're going to need something to get a colour out of the palette. Get colour, and we'll pass a double in. Now what we're going to do, we're going to use, if the value is negative, that's going to represent a inner colour. What we'll do is if we'll say if val is less than 0, then we return inner colour. Otherwise, we're going to return a value from the palette. Now that's going to be our value multiplied by p-scale, and this is what the p-scale is. It basically scales the iteration result by a fixed value, and it sort of spreads out the colours across the set, and it makes the set more consistent as you change the number of iterations. This is going to have to be an int, so let's convert it to an int, and we're going to modulo that with the palette length. We're also going to need a way to transform an XY coordinate from the pixel space into the complex space. I think we'll do this as a tuple. So this is going to return basically a complex number. So double A, double B. Okay, and this is going to accept a coordinate, which is int x, int y. So we're going to return, oh God, this is going to be bracket city. The first thing we need to do is to take away half of the width from x, and this shifts the origin from the left hand side to the middle. Okay, and this needs to be divided by our magnification factor. Okay, and all of this we then need to add the offset. Okay, so that's one of them, and the second one is going to basically be the height. So let's just give it a, so we're going to be manipulating bitmaps, so it'll be easier just to be able to create one within the height and width context that we've got set here. I think that will do for that. Okay, I've just fixed that. For some reason I did that with a lowercase c and didn't notice. Okay, let's go back to UI. We're going to need a color palette. Let's make a method which will create a color palette for us. with a palette, you want the start of the palette and the end of the palette to loop around, right? So if you say start the palette at red, then it needs to end at red, so that the colours loop around and you don't get bands. But usually what you tend to do is you start at black and end in black, and this sort of gives like a fade in and fade out. So I think what we're going to do is we're going to start at black, then we're going to go to, let's say, yellow, then we're going to go to red, then to magenta, to blue, then to cyan, and then from cyan back to black. The colours are going to be, so we start at black, which is obviously 0, 0, 0. So yellow is going to be 255, 255, 0. In actual fact, that's going to be 254, because the next one is going to go from full yellow. So that just needs to be a bit below yellow. Then the next one is going from yellow, and we're going towards red. 255, 1, 0. Okay, so that's the sequence we're going to use. So what are we going to need? We're going to need sequences. So let's use link for this. So var, we're going to have an increasing range. So it's going to be enumerable dot range. So an increasing range goes from 0 to 254. We start from 0 with a length of 255. Yeah, that will go from 0 to 254. So if we go on decrease, we go from 255 to 1. So what we need to do here is start from 1 and 255. That will give us a range going from 1 to 255, and we need to reverse it. We also need a range which is all 0. We've also got 255, and that's 255 repeated 255 times. Red range, we're going from black to yellow. So here we've got red and green increasing and blue being 0. So red is increasing, green is increasing, and blue is 0. We've got red, which is at the max value, green is decreasing, and blue is at 0. Alright, so for red we just need to follow this sequence here. So we've got starting with increase, so INCR, we'll concat maximum, so that's all 255, again all 255, then we're decreasing, then zeros, we count all 0. Okay, so now we just need to zip all of those up. Alright, so we can return, so we take the red range, and what we're going to do is zip that up with the green range, which will give us two parameters, R and G. So we're taking the parameter from the red range zipped with the parameter from the green range, which gives us R and G, and then we're creating a tuple R and G to be passed to the next sequence, which is also going to be a zip, and this time we're zipping up the blue range. We'll call this RG, which will be the tuple from the previous one, and then just the standard int B. Form that into a three-way tuple, which is going to be red, green, red, red, green, green, and then the blue. So now we can select, and that three-way tuple we'll call RGB. We'll just create a color from RGB. That's going to be RGB red, green, RGB blue, and finally convert that to an array, and that should do it. Link always gives me nightmares because it's so unreadable. Alright, let's create a new class now, which we're going to use for the Mandelbrot calculations. So this can be static. So let's do the iteration function first. Iterate. We'll accept a tuple, I think, so double A and B. And that's going to be the value C, which is under test. And then we're also going to need the number of iterations that we need to use. Okay, so we're going to have to define a value Z. So we'll do that again as a tuple. And this starts at 0, 0. So we need to loop through all the iterations. Actually, we'll start at 0. You'll see why in a minute. Alright. If you remember the function, the first thing we need to do is square Z. So to square Z, to get the real part, we take b squared away from a squared. Let's make a temporary value and we'll store ZA. This is the real part. ZA times ZA, take away ZB times ZB. Then ZB, 2 multiplied by ZA, but we just changed ZA there, so we have to use T. That's why we needed that temporary value. So T times ZB. So ZA plus equals CA, and ZB plus equals CB. Now we need to check if the magnitude is above 2. But before, in the old video, I actually took the square root. There's no need to do that, because instead of just checking if the square root is greater than 2, you just need to square A and B, add them together and check if it's greater than 4. It's the same thing, but it stops you needing to do the square root, basically. And this time it's square of A plus ZB times ZB. Now, if that is greater than or equal to 4, then we can return the number of iterations. And here we can return -1, which indicates it's inside the set. Now, this isn't very optimized, because if you look here, we're doing this squaring here, and then we're doing the squaring again here. If we just saved what we square here, we can reuse those up here. I'm going to create another tuple called ZS for Z squared. And what I'm going to do here, Z squared A is equal to ZA times ZA, and then Z squared B times B. To replace all of that there with Z squared A, all of that there with Z squared B, and then up here I can do the same thing. Right, so that saves us having to do that squaring twice. So let's do ZB first, then we can actually use ZA there, no problem. Now we can set ZA using Z squared, so we don't need the temporary variable anymore. Now, there is something else we need to do here as well, and it has to do with the color banding. So let me see if I can explain why we need to do this. So here's a number line, and let's say this is the number 2. Right, so as we do the iterations, right, we're going to get magnitudes back along each iteration. So first iteration, second, third, fourth, fifth, sixth. The 5th iteration is below 2 and the 6th is greater than, so it would exit at this iteration here and return the value 6, because the 6th iteration caused it to exit. But as you can see, it's quite a long way away from 2, right, because 2 is the actual value that we're escaping on. I mean, in the application it's 4, but essentially it's 2. And if you look here, 2 is much closer to this point than it is to that one. So it would be more accurate to say that instead of this being iteration 6, it's more like, I mean, this is about a quarter of the way. It's more like iteration 5 1/4. You see what I mean? This was the penultimate iteration. So let's say it's, I don't know, iteration 10. And then this is the final iteration, which is iteration 11. Okay, so we'll call this P. We call this L. What we actually want here is, instead of it returning 11, we want it to return 10 1/3, or 10.333, or whatever, right? So how can we do that? Well, we need to figure out where 2 is relative to these 2 points. So first of all, we want to shove all of these 3 points back so that P is at 0. So in order to make a number 0, you take it away from itself. So we need to do that with everything. This point here is now at 0. We want this point at the 11th iteration, we want that to be at 1 on the number line. So to make a number equal to 1, you divide it by itself. And we do the same with everything else. And there's no need to do it with that because it's already 0. So this is what we need to do. Yeah, we need to keep track of the magnitude of the last iteration before the one that caused us to escape, and then add this value on. Classically, you'll count from 1, iteration 1, 2, 3. So this would exit on iteration 11. But if we count from 0, right, this would become iteration 10, and then we would add this on, so we'd end up with like 10 1/3, which is correct. So that's why we're counting from 0 in that iteration loop rather than counting from 1. But this is exactly what we need to fill in the gaps between the iterations to make, and this basically makes the colours smoother. It makes them more of a gradient without having these harsh bands in there. So let's implement that now. So we need to keep track of the old magnitude. So let's create a double old mag. And also we're going to need to use, we're going to do this addition here, and then we're going to need to use it again here. So we'll actually pre-calculate it. So we're only doing the addition once. So we can set m to be equal to z squared a and z squared b here. Then we can just use m is greater than 4 there. As we saw before, it was, I used 2 in that illustration, but here we're using 4. It won't make much of a difference. So this is just going to be 4 minus the old magnitude, and then this is divided by the latest magnitude, take away the old, and then after that we just need to set the old magnitude to the current one, and that's it. That should be our iteration function with all the smoothing enabled. Now, if you recall, I said I was going to use multi-threading for this. The way I'm going to do it is when you create a bitmap, it creates it with a transparent background, and that will allow us to create, if we say have 4 threads, we can create 4 bitmaps and render every 4th line on each bitmap, and then we can just sort of squash them all together because all the intervening lines that aren't drawn are transparent. So we can then just draw them all on top of each other to get the full frame. So we need something to draw one of these partial frames. It's going to return a bitmap. So we're going to need to know how many threads we are running. We're going to need to know what the current thread number is. We're going to need the context. And we're also going to pass in a, because this is multi-threaded, we're going to pass in a cancellation token so that we can abort it. You know, if you remember on the UI, I put an abort button. So this is what this is for here. So first of all, let's create our bitmap. So we need to go through each pixel. So we'll start with the Y coordinate. Now here, we're going to draw every so many lines, right? So we need to start Y from the current thread number. Okay, so we need to check that Y is less than the current contextual height. And also we'll check if the cancellation token has been set here. We need to increase Y by the total number of threads in use. Okay, we can just loop through X as regular. So number of iterations is going to be, we need to call iterate, and it gets a tuple, the complex number under test, but we've got a pixel coordinate, so we need to transform it. There we go. And then max iteration, which is in context. So that will iterate that point and give us the number of iterations. So we just need to set the pixel, and then we're setting it, and in context we've got get color, remember, and that's it. We just need to return bm. So that will render a partial bitmap. So now we need something which will coordinate all of that and run them all, and this is going to need to be async because it's going to be run from the UI. This is going to be called from the UI, so we need it to be async so the UI doesn't lock up. Task, and it's going to return a bitmap. Okay, so we need to pass in the context, the number of threads we want to use, and we need the cancellation token. This is the master bitmap. This is the main bitmap that we're going to be returning, and with this bitmap we're going to need a graphics object because we're going to be drawing each of these bitmaps that partial produces onto this main bitmap. So we need the graphics object to do that. And we use using to make sure it gets disposed. How are we going to start these tasks? Let's use a link. So we're going to need to create a task collection which we can loop through. So this is going to be a range going from 0 to the number of threads. And we're going to select, which is going to give us the thread number. Run a task here, and this task is also going to return a bitmap. And then we're going to run partial, which takes threads, thread number, context, and token. And we'll also pass the token into the runner, and then convert that to an array. Right, now we can loop through each of those tasks, and we can say using task here so that the task gets disposed of. And this is a partial bitmap. It's going to be equal to await task, because that task will return bitmap. And then we can G draw image, and we're going to draw the partial bitmap at point empty, which is basically 0, 0. Once that's finished, we return bm. In fact, what I'm going to do there as well is put using there, because bitmaps need to be disposed. So yeah, that should work. Yep, I think that's okay. So that should do the rendering. Okay, these methods can be private. I had them as public before, but no need for them to be public. So let's test this out now. We need to make sure this is working. I'm pretty confident it will, but we really should test. UI designer here. We'll attach an event to the render button. Let's make this async temporarily. So context con equals new palette. So that's create palette, and the inner color is set to black, and we need a cancellation token. So con set values, palette scale, then we have view offset zoom, width. Well, that's going to be the width and height of the picture box element. Max iterations. Okay. So let's grab a bitmap. So bitmap BM. Right, we need to await that. So await Mandelbrot render. Pass in the context, the number of threads, and token. And now just set preview control background image to be equal to that bitmap. So this is our test code. No errors. So let's see if that runs. Okay, there we go. It looks like OBS isn't capturing the title bar of that window. It doesn't matter, you can still see it. So let's see. Hit render. Well, there we are. Seems to be working. The set is pushed all the way over to the left, but we can fix that. Form designer again. And we'll change the view offset. The horizontal view offset will change to negative 0.5. Hopefully that. There we go, that's better. So that is indeed working. So let's see if we can change things up here. So let's try changing the palette scale. Change it to 50 and see if that actually, yes, yeah, that is working. If we change the magnification, let's change that to 1, we should zoom in. Yes. Let's move our view a little bit vertically. Yep. So test successful. Let's get this implemented properly. Okay, so because of the way OBS seems to be capturing this window, I don't know why it's doing it, but what I'm going to do is I'm just going to put cell border style here in the main table layout panel. I'm just going to set that to inset double. And it looks pretty ugly, but the idea here is that it's going to define the edges of the window a little better. So it's going to be more, but yeah, that's better. You can see the edges of the application window better in OBS because it's not drawing the window decorations for some unknown reason. Now I'm going to save this code here. Set context method, which is just going to do all of that. Okay, we don't need the rest of this now, and we can get rid of that async. Con does not exist. We need to create a context object. Let's actually call that context. I'm going to make it a field. There we are. Okay, so we've got an event on render button. So we're also going to need an event on the abort button. Okay, and we also need an event on the preview windows. When you click on it, you want to zoom in to where you click. So we'll set an event on click for that as well. Okay, so how are we going to do this? Let's make a show preview. Okay, we're going to have to do it with two methods. This will be the first one. So if we show preview here, call is going to create a task which we've got to dispose of. Right, so we're going to have something to store the task which was previously used. Private task be nullable. This is the preview task, and this is null. There we go. Alright, so here we're going to be using the preview task. And the way this is going to work, every time we create a preview, the task from the one we created previously will be disposed. So that sort of keeps track of itself. We're going to need another function to actually call the rendering. Let's create, and this is going to have to be async. So private async task render set. Now something I want to do here is when we click preview or when we click on the preview window to zoom in, I want to disable the controls so that we can't click again while the image is being rendered. Let's create a function to let us do that. So private, the controls we need to mess with are the preview control window itself, the render button, and the abort button. Preview control, change the enabled, and this is going to be not busy. Render button. Now the abort button needs to be the opposite of that. So that actually needs to be busy. Okay, there we go. So when we come into render set from show preview here, we can call busy, and then that will disable all those controls so that they can't be clicked again. Now we can call set contacts, call Mandelbrot render method, but that needs a cancellation token if I remember. Yes. Okay, so make a cancellation token in a using block here. So let's make it a field, because obviously we're going to need to access that if the abort button is pressed. Cancellation token source CTS, we'll make this nullable. So here we can create a new cancellation token source. The Mandelbrot render function returns a bitmap, so we can directly set that to the background image of the preview control. And this is async, so we await this. Let's call it Mandelbrot render, pass in context, number of threads, and the token. And then after all of that is done, because this is going to await on this, so once that is finished we can release the controls so that they can be used again. So busy false. Right, so in show preview here we need to call render set. We just set now preview task to be equal to render set. So that stores the task of this async method running, and this will obviously wait here, release control back to the UI. Then as soon as this task is finished, it will set the background image and release all the controls. And then the next time we press render or zoom in, this using will dispose of the task that we used previously. Let's see if that's working then. Doesn't seem to be. Oh, yeah. Need to call show preview, don't I? Okay, there we go. Yeah, you can see here how the abort and render button are swapping places. So the cancellation, since we're passing this token in, we should be able to abort here. So if we say CTS cancel, that should allow us to send a cancellation request into this render thread. In fact, I'm being overly cautious here, but I'm going to create an extension method to cancellation token source. Safe cancel, cancellation token source, CTS, and we're going to cancel here, but we're going to encapsulate that in a try catch. And we're going to catch object disposed, I believe, is the exception. And then in here, we'll say safe cancel. Just in case for some reason we end up trying to cancel a disposed cancellation token source object. So let's test the cancel function. So if I set the iterations here to some crazy value like 200,000, it should take forever. So let's see if clicking abort, yes. Yep, that does indeed abort it. So I think the only thing we've got left is the magnification, the zooming in. So this is in this here where we click in the preview window. We want two functions, zooming in, zooming out. So let's switch on the button that was pressed. So E button. Oh, I've set the wrong type of event here, sorry. What we actually want is mouse click. There we go. We can get rid of that one. Now switch on the button, that's better. Only the left and right button, so any other button is going to be a default case. Why have I put case default? It's just default. Mouse button left, mouse buttons right. So if we click left, we want to zoom in. So we can do that just by adding one to zoom, and to zoom out, we take one away from zoom. Wherever we click in the preview window is where we want to zoom into. So that's going to become our new offset. we can transform into the complex plane, remember, because we've got that ability in the context. If we say context transform, and then we need where we've clicked, which is going to be e.x and e.y, we can break that tuple that returns into two values like that. And then we just need to set the offset. There we go. And here we can set show preview. Also, I mean, show preview will set context, but the thing is here, we're running transform, which is part of context, and it needs to know the width and height of the preview window, but that could have been changed because the window might have been resized. So we just have to make sure that that's taken into account. So we need to just call set context at the start here. Actually, we don't need to do it there, do we? We do it here, and that just makes sure context is aware of the correct width and height of the preview window. Something else I'm going to do as well. I'm just going to call show preview right at the start here, just so that we get a basic full render at the beginning. There we go. All right. So let's see if we can zoom in. Zoom in on the Seahorse Valley. Yes. Right. So we start to lose detail as we go in like that. So get more detail, we increase the number of iterations. Oh, let's go up again. Something's not right. Yeah, where I clicked there, that should have come into the middle, and it didn't do that. Why didn't it do that? It shouldn't make a difference. Let's just see what happens if I put this up here. Yeah. That's strange. Why is that making a difference? Oh, because, right, okay. Yeah, okay. Fair enough. It's a little inefficient, but it doesn't really matter. It only happens when you click in the preview window. So, yeah, okay. I think that's it. So, let's just have an explore around this set. And we'll go down here, because we get interesting images down here. Let's go up to 200 iterations. Let's go mad. There we go. We'll go up to 8 threads, so it's a bit faster. I'm just going to knock the palette scale down a little. Let's go up to 250 iterations. Alright, let's zoom in on that area there. $300. Oh, that's funky. And drop the palette scale a little more. No, I don't like that. Let's go up to 21. Right, let's try more iterations. 350. Wow. We've got like a spiral thing. That spiral should go on forever, you know, you can keep zooming into it. What are we on? Okay, we're at magnification 34 now. 2 to the power 35. So I want to demonstrate what happens when we zoom in too far. Go to 400 iterations. Right, we're getting close now. We can go up to around about 45-ish before it starts doing dodgy stuff. Yeah, I can just start seeing it now, starting to get pixelated. So just going to go to slightly higher. Right, so as we zoom in now, you should start seeing detail become more and more pixelated. Yeah, definitely noticeable now. Yeah, look at that. See, now we're running into the precision limit of a double, and it results in this sort of blocky rendering. And of course we can zoom out. And about 45 there, as you can see, is about the limit we can reach without that happening. So there we go. That is pretty much it. So what I'll do, I'll drop this onto, I've already started a repository there, but I'll finalize this and drop the code on GitHub in case you want to play with it. But it's very basic, but it is functional, and it's good enough just to, you know, as a reference. So there we go. Project successful. See you all later. Bye.